Hello friends, welcome to Maths Practice. Today we are going to start with a new chapter which is Introduction to Trigonometry. Trigonometry is a new concept and it has wide applications in the future. So watch the video till the end to learn about the basics of trigonometry and don't forget to subscribe to Maths Practice. Since trigonometry is a new concept for you, let us understand its meaning. Trigonometry consists of tri meaning 3, gon meaning side and metry meaning measure. Trigonometry is a study related to the measure of sides and angles of a triangle and it has immense application in science. Let us imagine from our surroundings where right angles are formed to understand the applications of trigonometry. Suppose the students of a school are visiting some TV transmission center. Now if a student is looking at the top of the TV tower, a right triangle is imagined to have formed. Now can the student find the height of the TV tower without actually measuring it? Or suppose imagine another situation where right angle is formed. Suppose a boy is sitting on the top of a lighthouse. He is looking down and observes a ship steady at the sea. Now again here a right angle is imagined to have formed in this situation. Now suppose if we know the height of the lighthouse at which the boy is sitting, can we find the distance of the ship from the lighthouse? Yes, using the concepts of trigonometry. To start with, we need to remember some important trigonometric ratios. The trigonometric ratios of an acute angle in a right angle triangle means suppose if you are having a right angle, the other two angles will be acute angles. So you can define the trigonometric ratios for the other two acute angles. It expresses the relationship between the angle and the length of its sides. There are 6 such ratios. Suppose you have a right angle triangle with right angle at angle B and let us define the ratios for the acute angle A. First is sine of angle A. It is equal to the side opposite to angle A upon hypotenuse, or from the figure it is BC upon AC. Cosine of angle A. It is the adjacent side to angle A upon hypotenuse. Adjacent side to angle A is AB upon hypotenuse AC. Tangent of angle A is opposite side upon adjacent side or BC upon AB. Cosecant of angle A is 1 upon sine or hypotenuse upon opposite side, which is equal to AC upon BC. Secant of angle A is 1 upon cosine or hypotenuse upon adjacent side, which is equal to AC upon AB. And cotangent of angle A is 1 upon tangent, which is equal to adjacent side upon opposite side or AB upon BC. Now first thing is there are some abbreviations used or short form used for this. SINE, sine, is always written as SIN, sine of angle A, cosine as cos, COS cos, tangent as TA and tan, cosecant as cosec, COSEC, secant as SEC, sec, cotangent as COT, cot. So sine, cos, tan, cosec, sec and cot. Now if you remember sine and cos, other ratios will automatically follow. Now some things to remember regarding the trigonometric ratios. As I told you, if you know sine and cos, other ratios will follow. Sec is 1 upon cos and cosec is 1 upon sine. You can remember it is reverse. For S it is C, for C it is S. Tan is sine upon cos and cot is cos upon sine. So tan and cot are also inverses of each other. The value of trigonometric ratios of an angle do not vary with the length of the sides if the angle remains the same. Why? Because you know that if I say for example tan 45 degrees is 1, whatever is the size of the length of the sides of the triangle, if the angle made is 45 degree, then the value of tan will remain 1. So if you change the sides, the values of angles will not change. Since the hypotenuse is the longest side in a right triangle, the value of sine A or cos A is always less than or equal to 1. And the value of sec A or cosec A is always greater than or equal to 1. This is very much obvious because you know how it is defined. Sine is opposite side upon hypotenuse and hypotenuse is the longest side. So the ratio will be less than 1. Similarly for cos. If one of the ratios is known, remaining can be found. Also, suppose if I want, say, the power of sine theta or sine phi, so I will not write as sine phi square. It is written as sine square phi. Both are the same things. Let us take some simple examples to understand the trigonometric ratios. In triangle ABC, if AC is phi, BC is 13, measure of angle A is 90 degree, means A is the right angle. Find all the 6 trigonometric ratios for angle B. Now since we find the length, first thing is what we do is we find the length of the third side, because the length of two sides is given. So since it is a right angle triangle, we can use the Pythagoras theorem. BC square is equal to AB square plus AC square. So when you put the value of BC and AC, you get the value of AB as 12. So now we have the lengths of all the three sides. First thing is you have to find all the ratios for angle B. So first thing is sine B. Now we know sine is opposite side upon hypotenuse. So which is the side opposite to B? It is AC. So sine B is AC upon hypotenuse BC is equal to 5 by 13. Cos B is equal to adjacent side upon hypotenuse. Which is the side adjacent to angle B? It is AB. So cos B is AB upon BC or 12 by 13. Tan is basically sine upon cos, correct? So it is equal to AC, means the opposite side, upon AB, the adjacent side. Okay. So as I told you, if you remember sine and cos, other things will follow. Tan is sine upon cos or 5 by 12. Cot is cos upon sine, correct? Or adjacent side upon the opposite side. So it is AB upon AC, 12 by 5. Sec, again I told you S, and for sec it will be C. So sec B is 1 upon cos and cosec B is 1 upon sine. So when you put those values, you get sec B as 13 by 12, cosec B as 13 by 5. Example 2. In triangle ABC, if measure angle C is 90 degree, tan A is 1 upon root 3, find sine A and cos B. Now first thing is we are given C is the right angle and tan A is given. What is tan A? Tan A is opposite side upon adjacent side. So tan A is equal to, which is the opposite side to angle A? It is BC, correct? And adjacent side to angle A is AC. Tan A is BC upon AC and that is given to be equal to 1 upon root 3. Now just bring root 3 on this side. So it will be BC upon 1 is equal to AC upon root 3. Let us assume that BC upon 1 is equal to AC upon root 3 is equal to some value K. So BC upon 1 is K, so BC is K. AC upon root 3 is K, so AC is root 3K. Now by Pythagoras theorem, AB square will be equal to BC square plus AC square. So just put the values. So you get over here AB square as 4K square, or AB is equal to 2K. Now what is sine A? Sine A is opposite side upon hypotenuse. Opposite side is BC upon hypotenuse AB. So sine A is K upon 2K or half. Similarly, now you need to find cos B. Remember cos, now angle has changed B. Cos B is adjacent side upon hypotenuse. Which is the adjacent side to angle B? It is BC upon hypotenuse AB. So cos B is BC upon AB, which is again equal to K upon 2K or half. Next, we are discussing the different types of examples which are based on the trigonometric ratios. Next is, if cot phi, phi is any angle, is 7 by 8, evaluate the value of 1 plus sine phi into 1 minus sine phi upon 1 plus cos phi into 1 minus cos phi. Now see, since these ratios are defined for a right angle triangle, we will imagine a right angle triangle at right angle B. So now we are given cot phi. Phi is any other angle, any other of the two acute angles. So let angle C be phi. Now it is given cot phi is given to us, but what is cot? Cot is adjacent side upon opposite side. So angle C is our angle phi, which is the adjacent side to angle C? It is BC, and which is the opposite side? It is AB. So now it is given cot phi is 7 by 8, which is equal to BC upon AB. Now just bring on the other side, so you get BC upon 7 is equal to AB upon 8. Again let us assume this is equal to some quantity K. So BC upon 7 is equal to K will give BC is equal to 7K, and AB upon 8 is equal to K will be giving you AB is equal to 8K. Now we will use the Pythagoras theorem. See, this is the reason why we had imagined a right angle triangle. So by Pythagoras theorem, AC square is equal to AB square plus BC square. Just put the values, so you get AC square as 113K square, or AC is equal to root of 113 into K. Now what we have to find, in that we need to find sine and cos. So first thing is sine phi. Again angle C is phi. So sine phi is opposite side upon hypotenuse. So which is the opposite side to C? It is AB. So sine phi is AB upon hypotenuse AC. Just put the values, it is 8 upon 100 root of 113. Same way cos phi is adjacent side upon hypotenuse. Which is the adjacent side to angle C? It is BC. So cos phi is BC upon hypotenuse AC equal to 7 upon root 113. Now in the given equation, just put your values of sine and cos. But before that, now you have already studied the identities. You know A minus B into A plus B is A square minus B square. So first we can use that to simplify the equation. So what we have actually is 1 minus sine square upon 1 minus cos square. This is equal to 1 minus, put the values of sine and cos. So you get over here 1 minus 64 by 113 upon 1 minus 49 by 113. So this gives you 49 by 64. So the value of what we need to find out is 49 by 64. Also over here you can observe that directly if you square cot phi, that will also give you 49 by 64. Now these are some equalities which you will be studying further. Also this same example can be solved easily if you know some trigonometric identities. But from trigonometric ratios, this is how you need to solve the example. Now some trigonometric ratios of some specific angles. Remember, this is very important. You need to know this. Correct? You need to remember this. Now since it is a right angle triangle, you have 0 to 90 degree. From that some important measures are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. For these angles, means theta is the angle, for these angles you will remember the value of all the trigonometric ratios. Again I am telling you, if you remember sine and cos, other things you can remember. It follows from sine and cos. Also I will give you a tip how to easily remember this. First of all, we start from 0 degree and sine theta. Sine theta is 0 for 0 degree, means sine of 0 degree is 0, sine of 30 degree is half, sine 45 degree is 1 upon root 2, sine 60 degree is root 3 by 2 and sine 90 degree is 1. Same way, cos of 0 degree is 1, cos 30 degree is root 3 by 2, cos 45 degree is 1 upon root 2, cos 60 degree is half and cos 90 degree is 0. Tan is sine upon cos. So 0 upon 1 is 0. 1 upon 2 upon root 3 by 2 is 1 upon root 3. So just you need to do is sine upon cos. So tan 45 degree will be 1. Tan 60 degree root 3. Tan 90 degree will not be defined. Why? Because 1 upon 0 is not defined. Same way cot is opposite or inverse of tan. So again 1 upon 0 is not defined. So cot 0 degree is not defined. Cot 30 degree is root 3, 45 1, cot 60 degree 1 upon root 3. Sec is 1 upon cos. So sec 0 degree is 1, sec 30 degree is 1 upon root 3 by 2 or 2 by root 3. Sec is 1 upon cos. Sec 45 degree root 2, sec 60 degree 2 and sec 90 degree not defined. Cosec is 1 upon sine. Correct? So again 1 upon 0 is not defined. So cosec 0 degree is not defined. Cosec 30 degree is 2. Cosec 45 degree root 2. 60 degree 2 by root 3 and cosec 90 degree is 1. Now you don't need to proof is simple based on trigonometric ratios, but you just need to remember these ratios by heart. Now a easy trick is, as I told you, if you remember sine and cos, other ratios will follow. For remembering sine and cos, what you do is whenever you are in the exam, just make columns 0, 30 degree, 45 degree, 60 degree and 90 degree. From 0 to 1, just go on putting values. Say first I am writing 0, 1/4, half and 3/4 and then 1. Now take the square root of that. 0 square root is 0, 1/4 square root is half, half square root is 1 upon root 2, 3/4 square root is root 3/2 and 1 square root is 1. So now you get all the values for sine, correct? Cos is just the reverse of sine. So cos will be 1 root 3/2, 1 by root 2, half and 0. Okay, so this is the trick how you can remember. In the next example, you have to state whether the following statements are true or false. Remember, these type of questions are asked and you have to give the reason for stating whether they are true or false. First is sine phi is 3/2 for some angle phi. This is not true, it is false, because you know sine and cos both are less than or equal to 1. So even for cos it will stand false. Next is cos phi is 2/3 for some angle phi. This can be true. The reason is because its value is less than 1. Cosec phi is 5/2 for some angle phi. What is cosec? Cosec is 1 upon sine. Since sine is less than 1, 1 upon sine will be greater than 1. So cosec phi 5/2 is possible. The value of tan A is always less than 1. That is false, correct? You know that tan 45 degree is 1. Even tan 60 degree will be more than 1. Cos phi is 100. Obviously not possible. It should be less than or equal to 1. Cot A is the product of cot and A. That is not true. Cot is cos upon sine and A is some angle. The value of sine theta increases as theta increases from 0 degree to 90 degree. This is true because you know sine 0 degree is 0, sine 90 degree is 1. So it increases. But suppose if it is given for cos, the statement would be false. Cos A plus B is equal to cos A plus cos B. This is also false. Why? You can give any example. Suppose if I take A as 30 degree and B as 60 degree, cos of 30 plus 60 degree means cos 90 degree is 1. But cos 30 degree is root 3/2, cos 60 degree is half. So 1 is not equal to root 3/2 plus half. Tan 90 degree is not defined. It is true because tan 90 degree is sine 90 degree by cos 90 degree. Sine 90 degree is 1, cos is 0. So 1 upon 0 is not defined. The value of cot theta increases as theta increases from 0 to 90 degree. This is false because cot is cos upon sine, correct? So cos obviously decreases from 0 degree to 90 degree. So the value of cot will also decrease, but for tan it will not be the same. Now the trigonometric ratios of some complementary angles. Two angles are said to be complementary if their sum is 90 degree, correct? So for two complementary angles, how will you define the trigonometric ratios? Sine of 90 degree minus A. If A is an angle, 90 degree minus A is its complementary angle. So sine of 90 degree minus A is cos A. Cos of 90 minus A is sin A. Tan of 90 degree minus A is cot A. And cot of 90 degree minus A is tan A. Similarly, sec of 90 degree minus A is cosec A. And cosec of 90 degree minus A is sec A. Correct? Now some important things which you might have already noted from the table. Tan of 0 degree is same as cot of 90 degree, which is equal to 1. Sec of 0 degree and cosec of 90 degree both are 0. Sec 90 degree, cosec 0 degree, tan 90 degree and cot 0 degree are not defined. Now some examples to make the idea of trigonometric ratios very clear. If sec of 4a is equal to cosec of a minus 20, where 4a is the measure of an acute angle, find the value of a. Sec of 4a is equal to cosec of a minus 20. This is given to us. But if I want to write cosec in the form of sec to compare both the sides, we know that cosec of a minus 20 can be written as sec of 90 minus a minus 20. Correct? Because sec of 90 minus angle, any angle is equal to cosec of that angle. So cosec of a minus 20 is written as sec of 90 minus a minus 20, which is equal to sec of 110 minus a. Now both sides you have sec, so compare the angles. 4a is 110 minus a, which gives the value of a as 22. Here we have used the complementary angles. Express the following in terms of trigonometric ratios of angles having measure between 0 degree and 45 degree. Correct? If the angle is not between 0 and 45 degree, you have to make it between that. So sine 70 degree plus sec 62 degree. Sine of any angle A is equal to cos of 90 minus that angle A. So sine 70 degree can be written as cos of 90 minus 70. Same way sec of 62 degree can be written as cosec of 90 minus 62. So now what has happened? Both the angles have changed into angles between measure 0 degree and 45 degree. So it is equal to cos 20 degree plus cosec 28 degree. Second one, cos 79 degree plus tan 59 degree. Cos of any angle A is sine of 90 minus A. So cos 79 degree can be written as sine of 90 minus 79, and tan of 59 can be written as cot of 90 minus 59. So this is equal to sine 11 degree plus cot 31 degree. Next example. If A, B and C are interior angles of triangle ABC, then show that sine B plus C by 2 is equal to cos A by 2. Now here, since B plus C and A is given, we know that the sum of the three angles of the triangle is 180 degree. So A plus B plus C is 180 degree, which gives B plus C as 180 degree minus A. So B plus C by 2 is 180 minus A by 2, or 90 degree minus A by 2. Now you know the formula for the complementary angle. So sine B plus C by 2 is sine of 90 degree minus A by 2. But what is sine of 90 minus any angle? It is cos of that angle. So sine 90 degree minus A by 2 is cos A by 2. Next example, if sine A minus B is half, cos A plus B is half, 0 degree less than A plus B less than or equal to 90 degree, A is greater than B, find A and B. You have to find the value of measures of angle A and B. Now since sine of A minus B is half, A minus B has to be 30 degree. We have seen in the table, I told you have to remember that table, for which angle sine value is half, 30 degree. So our angle A minus B is 30 degree. Similarly, cos A plus B is half. So cos is half for angle 60 degree. So A plus B is 60 degree. So just two equations, A minus B and A plus B. Solving the two equations, you get A as 45 degree and B as 15 degree. Next important example. Find the value of tan 1 degree into tan 2 degree up till tan 89 degree. Now see, over here we are going to use the concept of complementary angles that we have studied. Tan 1 degree into 2 degree into 89 degree. So now first thing is tan 1 degree into tan 2 degree into tan 3 degree and so on. In between you will have 44, 45, 46 degree. And then at last you will have 87, 88 and 89 degree. So now see how we are grouping the terms. You know tan 45 degree is 1. Remember, this is very important. It is used many times. Tan 45 degree we have just seen from the ratios table. Tan 45 degree is 1. Similarly, cot 45 degree is 1. And also remember, tan into cot will always be equal to 1. So now tan 45 degree is 1. Tan 46 degree can be written as tan of 90 minus 44 degree. What is 46? 90 minus 44. Same way, 87 can be written as 90 minus 3, 88 as 90 minus 2 and 89 as 90 minus 1 degree. So now in the middle three terms, tan 45 degree is 1, correct? And the last three terms, tan of 90 minus 3 degree is equal to cot of 3 degree, because tan of 90 minus any angle A is cot A. So tan of 90 minus any angle A is cot A. So tan of 90 minus 3 is cot 3 degree. Tan of 90 minus 2 is cot 2 degree. And tan of 90 minus 1 is cot 1 degree. So now what we do is, see, in between terms will also follow in a similar manner. So now how do we group the terms? With tan 1 degree, you take the cot 1 degree. With tan 2 degree, cot 2 degree. Tan 3 degree, cot 3 degree. Similarly, you will have tan 44 degree and cot 44 degree. In between tan 45 degree is 1. Now tan into cot is 1. So you get 1 into 1 into 1. That is equal. 1 into 1 into 1. How many times? 44 times. So that is equal to 1. Now some assignment examples. First, if cos 9 theta is equal to sin theta and 9 theta is less than 90 degree, then find the value of tan phi theta. The answer is 1. If 4 tan theta is equal to 3, then evaluate 4 sin theta minus cos theta upon 4 sin theta plus cos theta. Here, since the value of tan is given, the hint is you can divide the equation by cos theta. Answer is half. Third one, find the value of the given expression. Now, the answer for this is 2. Here you can use the concept of complementary angles, ratios of complementary angles. Also, you will need to use the identity sin square theta plus cos theta is equal to 1. Friends, in the next video, we are going to discuss a very important thing, which is trigonometric identities. So, don't forget to watch the next video. Friends, trigonometry is a very important chapter. In the part 1, we have seen the trigonometric ratios. In the next part, we are going to see trigonometric identities, which are also very important. Please do like and share this video, and don't forget to subscribe to Maths Practice for many such videos.